Hey there, welcome back to the channel. Today, I want to talk about touchscreens in Meadow, as well as just a quick example of how you prototype a UI application or an HMI on the desktop before you move it down to an embedded device. What I've got here is a very simple demonstration app that will draw circles. Basically, when I touch the touch screen, it will start drawing a circle. It will inflate as long as the touch is down, and then when you lift, it stops inflating it. And then when you move somewhere else, touch again, it will draw another circle. So I've encapsulated basically all of that logic in this class I'm calling Circle Demo. It takes in a display screen, so this is a micro layout display. This will be our output, and then an iTouchscreen interface. So the iTouchscreen is the input from it. And so what we're looking for is the touch down and touch up. And again, what we're doing is we're inflating. I'm just using a timer. It inflates by 2 pixels at a rate of 20 milliseconds. So you can see here, when we touch down, it's just going to create a new circle, fill it with a random color, and then add it to the list of controls, and then start the timer. And then as the timer ticks, it's just going to inflate the size. What I would normally do here is I've created this as a desktop application. So you can see here that I just have a Meadow desktop app, so it's targeting desktop. I create the touch screen. It's interesting to note here that the display for desktop, whether you're on Windows, Linux, or Mac, does implement iTouchscreen because it's a mouse clickable. So it is both a display, an iPixel display, as well as an iTouchscreen. And so we create the micro layout display screen, passing that in, and then we create this Circle Demo class and start the demo. So if I just run this, here it is right here. It is fairly small because I am prototyping a 320 by 240 embedded screen. I do want to do some work and make this allow pixel doubling so it's a little bit friendlier. But so you can see now if I click down, it just creates that circle and inflates it. Real simple. You can see it's just randomly choosing. Take a look at the power of this though. If I close this app, and you can see that this is Circle Demo, and in fact you can see that this is a linked file. It is coming, in fact, from this project. So I have here a project that is an F7 core compute, and I'm going to run this on my project lab, and I have installed a touchscreen on it, a display with a touchscreen. So let's take a look at what that looks like real quick. You can see I've got a touchscreen here. I just have it wired in over to the microbus. On future revs of this board, it will be directly wired in. But for now, if you've got one of these, or if you're just using the F7 Feather, we wire it in and it's using the SPI bus. So you can see over here that I have to do a little bit of more work. So I create the project lab, but I created a display just like I did back here. I've got a display and I'm grabbing the touch screen from the project lab. This is some development work where the project lab will have the touchscreen controller built in, but you could create this as a separate part just as well. In fact, you can see that this is just an XPT2046, so I could just move this code over into my application here and generate the touchscreen. The one thing that we have that's different here is on the device, the touchscreen and the display are separate and they are not calibrated to one another. On your desktop, when you click on something, it knows exactly what that XY coordinate is in relation to your window. On an embedded device where the touchscreen and the display are different physical things with different controllers, you have to correlate the position from the touchscreen to an XY of the display. I've created a calibration service. This will be available as well, but that's not really my focus on this. So what we'll do is we create this calibration service, and then we calibrate it if it doesn't have calibration data. But once it is done calibrating, this is the important part. We run this circle demo, or we create the circle demo, which is the same as we did on our desktop app. And then in the run, we just call demo start. This is the desktop one. We just call demo start. So we're using the exact same code for handling touchscreen events, same code for drawing, same exact class, in fact. And so if I execute this, deploy this to the device, so you can see over here, this is that calibration screen that originally comes up. Since it's a small screen, we really only need 2 points for calibration. It's just doing a linear calibration. So if I touch that point and I touch that point, it is now calibrated. So the screen is at the point where we're running the demo, so it's identical to the desktop. And if I just touch down, so there you go. Touch screen on an embedded device. This is the F7. This would work on the F7 Feathers as well. You don't have to have the core compute module or a project lab in order to use this. It's just using SPI. In fact, you could use this exact same setup on a Raspberry Pi or on a Jetson Nano, anything like that. Anything that Meadow supports, so a wide array of things. The code for the application is identical. I'm using the exact same file between the two just to prove that. These touchscreen features are right now a work in progress. They are in the develop branch. It's effectively done. So it's in the develop branch if you wanted to play with it today. It will likely go out in our beta release, which happens every Tuesday, so this upcoming Tuesday. And it will go into the next future release. So depending on when you're watching this, it may already be out. But if not, the interfaces are already done. They aren't going to be changing. So you can pull the code in the develop branch today and start using it if you'd like. That's all I've got for today. Thanks for watching.